All right. So, when you're trying to derive acceleration and you have to use Newton's second law, one of the best techniques to do so is to first make the free body diagram. Now you can see the round object, which can be cylinder, disk, sphere. The weight component is pointing directly downwards. It has two components. One is mg sine theta, which is along the ramp, and then mg cos theta, which is perpendicular to the ramp. Mg cos theta produces a normal reaction, and there is a force of friction acting upwards. This force of friction is producing the torque, which is given by F into R. We will use this concept later. But let's first apply the Newton's second law now that we have understood the free body diagram. Look at the free body diagram very carefully. You can see that the downward force is mg sine theta and the upward force along the ramp is F. The net difference is equal to MACM. So when we are deriving linear acceleration in this, we're deriving the linear acceleration of center of mass of the round object. So I have used the expression ACM in this derivation. ACM means center of mass, acceleration of center of mass.